I am Dr. D.K. Tripathi, Assistant Professor of Physics under the Department of Basic Science and Humanities. Today we will discuss statistical mechanics. So before going to detail in the laws of statistical mechanics, let us try to know that what statistical mechanics is. So the word statistical or statistics was first coined for average. So this means that statistical mechanics is an average mechanics. Why it is an average mechanics, we'll discuss later on. Before that, we should know that what mechanics is. Now on the screen you are doing a switch, a force is acting. So in the mechanics, what we learn, the study of forces. That means here we will discuss that if we are discussing the mechanics, then we will discuss that what are the forces acting over this spring. So you see in the figure, the force, external force which we are applying is acting over the spring, and due to that there will be a resistive force which will try to keep it back in its original position. But in the Newtonian mechanics, we are using or we are considering only these two forces. But is that only two forces acting over the spring? No. As per the law of attraction given by law of gravitation given by Newton, what we know that there is a force acting always between two bodies. This means that there will be a force which will be acting on the spring due to you, due to each and every organ of you, due to sun, due to moon, due to other celestial bodies, due to trees, due to window panes, due to the doors, due to the rods in the window panes, due to the tiles. That means the force between all the bodies which are existing in the universe and the spring. But as per the Newtonian mechanics, what we will have to do, we will have to write the equation for each force as per Newton's second law of mechanics, and then to solve equations. But what we cannot solve these many equations, and also we cannot construct. So we will have to go for the approximation. What will be our approximation? Approximation will be that we will have to consider the major forces only. We will leave the minor forces. So what are forces? So what are the major forces here? The force is due to the external force which we are applying, the resistive force which is trying to keep the spring at its original position, the weight of the body, and the reactional forces. So only four forces we will have to consider, and other forces we will have to leave. So what we conclude, that what number of forces we are acting, we are reducing that number, and we are constructing these we are writing the equations for these forces, and then we will find the result due to them, interaction due to them. So here the result what we will get about the fate of the body. Fate of the body means that in which state the body is, because there are two states of the body. One is state of rest and other is state of motion. So if we will try to find out that what is the state of the body, then that can be got by F equal to ma. That means we will conclude that what A is, what is the acceleration. So fate of the body will be got by considering only these forces which are 4 in number here, but we are leaving all these forces. That is why the acceleration what we will calculate from this consideration will not be exact. Whereas in the case of the quantum mechanics, what happened, that each and every particle of a body is attributed with a wave function. Wave function gives the space and time behavior of each and every particle, and by solving the Schrodinger equation we come to know that what will be the fate of the body, what is the state of the body, and on that very basis we used to tell, or we used to used to give that where the body will be. So this is exact one. Now what in the average mechanics or statistical mechanics? In the statistical mechanics, using the laws and principles of the classical mechanics, but by incorporation of some mathematical tools like probability, permutation and combination, the result becomes more closer to the real one. So it's a mechanics which is giving the better result than the classical mechanics, but not as good as the quantum mechanics. That is why this mechanics is called as average mechanics or statistical mechanics. So we come to know that what is the difference between statistical mechanics and the statistical and the. Now the first topic in statistical mechanics is energy level and energy state. Now can you define that what is energy level? Energy level, if you go to the Bohr's atomic model, what we conclude that in the Bohr's atomic model, the electrons are revolving around the nucleus, and in the nucleus nucleons like proton, neutron, these are there. Now as per Bohr scheme, the electrons are filled up in the atom. So there will be one cell, there will be two cells, there may be three cells, there may be as many cells. So Bohr scheme is what? 2n square. If there will be 2 electrons, then that will be filled in the first orbit. If there will be more than 2 electrons, then that will be put in the second orbit. If there will be more than 10 electrons, then that will be filled in the third orbit. Now all of these are electrons. If you want to transfer the electrons from the first orbit to the second orbit, will it go? No. You will have to give this gap amount of energy between the first orbit and the second orbit, so that the electron from the first orbit will go to the second orbit. Like that, if you want to transfer the electrons from the second orbit to the first orbit, will it come? No. Until and unless you are extracting the gap amount of energy from the electrons in the second orbit, they cannot come to the first orbit. So what we conclude, that electrons are electrons, but we will have to extract or add some amount of energy or gap amount of energy to them to transfer them from first orbit to the second orbit, or second orbit to the first orbit. What does this mean? Energy of the electron is not fixed. The energy of these paths on which the electrons are revolving or the orbit is fixed. The energy of these paths or orbits are fixed. Now when these orbits or cells are leveled as horizontal line as shown in the diagram on the screen, then these orbits or the cells gives us a diagram in as horizontal lines, and this diagram is called as energy level diagram, and these levels are called as energy level. So what we conclude, that energy level is the horizontal representation of orbit or cell of an atom. Now what about the energy state? Energy state is quantum consideration. Energy state means exactly where the electron is. So we will have to know that, you see, energy level is decided by Bohr scheme 2n square. whereas energy state is telling us use that where the electron is exactly in the atom. So for that, what we will have to know, we will have to apply all the quantum rules of Bohr principle, Ohm's rule, Pauli's exclusion principle to know that what is the exact site or location of the electron. Ensemble. Ensemble is a Greek word which means assembly of particles. So in the statistical mechanics, we deal the behavior of the assembly of particles in a system. Based on this, there are three types of ensembles considered in the mechanics. First one is called as microcanonical ensemble. What is microcanonical ensemble? In microcanonical ensemble, what happens that there is non-transference of particles as well as the energy from one system to the other system. Whereas second type of ensemble is canonical ensemble. In the canonical ensemble, what happens that if there are two systems characterized by the extensive components like number of particles, total volume and temperature, then if we use a permeable membrane or semi-permeable membrane between them, then what happens that energy can be transferred from one system to the other system just to equalize or to achieve the same concentration, whereas there will not be flow of particles due to the semi-permeable membrane. Then this is called as canonical ensemble. Whereas in the third ensemble, which is called as grand canonical ensemble, there the particles as well as the energy is transferred to equalize. So that is called as grand canonical ensemble. So what we conclude that in the case of microcanonical ensemble, there is non-transference of particle as well as energy from one system to the other system. So concentration of the energy as well as particle is not same in both the compartments. Whereas in the case of canonical ensemble, the particles cannot be allowed to transfer, but the energy is allowed to transfer and to be equalized, and there is a flow of energy from higher concentration to the lower concentration. And in the third type of ensemble, all two are allowed to be equalized. So the energy as well as particles are flowing from higher concentration to lower concentration. Macrostate is made of two words, macro plus state. So macro means large and state means state. That means the state, due to the large size properties or bulk properties, or better to say extensive properties of the system of particles. Now what is extensive property? The property which depends on mass is called as extensive properties. So if state is by considering the macroscopic properties or by considering the extensive properties of the body, then that very state is called as macroscopic state. Now macroscopic state is due to these properties. So number of particles, total volume, then temperature, all these are extensive properties. So if there is a state due to them, then that will be macroscopic state. Let us try to understand this macro state in detail. For that, if we take a wooden box and let us make two compartments in it. Now suppose we are having four particles A, B, C, D. and we are keeping this box to a distance of 2 feet or 3 feet or 4 feet from us, and we are pelting these 4 particles in these 2 compartments. So here, if we throw these particles, what will be the possibility of distribution of particles? Here one thing we will have to take without loss of generality, that we are competent enough to put the particles in these 2 compartments, not anywhere else when we are throwing it. So what will be the distribution of particles? This will depend on different possibilities. There may be that no particle is falling in the first compartment, whereas all 4 particles are falling in the second compartment. So the distribution will be 0, 4. If we are finding that 1 particle is falling in the first compartment and 3 particles are in the second compartment, then the distribution will be 1, 3. If both of the compartments are having 2 and 2 particles, after our throwing, it will be 2, 2. And if there will be first 3 particles in the first compartment and 1 particle will be in the second compartment, then the distribution will be 3, 1. And if all 4 particles are falling in the first compartment and no particle will be found in the second compartment, then the distribution will be 4, 0. So what we conclude here, that there will be 5 possibilities of distribution of particles on the basis of number of particles. So these 5 possibilities are macrostate. Why? Because here on the basis of number of particles, the distribution are of 5 types. So that is why this is macrostate, which depends on the number of particles, and number of particles is always always a mass dependent property. So that is why the state due to the mass dependent property will be called as macrostate. So there will be 5 macrostate. Microstate. The word microstate is made of 2 words, micro plus state. Micro means small size. So if a state is due to the small size properties, that is intensive properties of a body, then that state is as microstate. So what is microstate? Let us try to understand. So in the discussion of macrostate, we have got 5 macrostates for the distribution of 4 particles in 2 compartments of the same box. Now let us try to realize any one of them. Suppose realization of macrostate 2, what we will have to do? We will have to keep 2 particles in first compartment and 2 particles in the second compartment on the basis of intensive properties of the particles. So how we will realize that? Because specification is to be done. Now you see, in the macrostate 2, we don't know that which 2 particles are in the first compartment and which 2 particles second compartment. So this macrostate is giving us that what number of particles are in the first and second compartment, but which particles are there, this is not specified. So we come to know that mass which is present in the first and second compartment is same, but what amount or what particles are there, we cannot conclude. So if you want to know, if we want to specify this distribution, then we will have to tell that which 2 particles are in the first compartment, AB, AC, BD, AD, which one is there. So based on that, if we try to distribute the particles, what we will get? We will get that if you put AB in the first compartment, then CD will be put in the second compartment. Then if we put AC in the first compartment, BD will be put in the second compartment. If we put AD in the first compartment, then BC will be put in the third compartment, and then if we reverse them, that CD, AB, then all other, so what we will get? We will get 6 number of distribution for distributing 2 particles in the first compartment and 2 particles in the second compartment. Now you look, what is the difference between them? In these distribution, as for the first AB and CD, what we are getting, that we come to know that which 2 particles are in the first compartment and which 2 particles are in the second compartment. So this distribution is minutely observed, and we come to know that what is the specification which is done here. The exact particle and is told to us, and also we come to know that how the total energy of the system is distributed. So we conclude that microstate is more specific distribution which is on the basis of identity of the particles. These are some of the references which you must pursue to know more about the topics. Thank you.